Now, when it comes to building out the tables or the database schema, SQL Alchemy has a little bit of a limitation, and that is that SQL Alchemy doesn't allow us to modify tables. It doesn't allow us to create extra columns, delete columns, add foreign key constraints. And that's because when we define these models, what SQL Alchemy does is it checks to see if the specific table name already exists in our Postgres database. And if it does, it's not going to touch it. So if we make any changes, it will never push out those changes. It'll only create these tables if it doesn't already see a table with that specific name. And so we've had to resort to dropping all of our tables and then restarting our application so that SQL Alchemy builds it from scratch. And it's something we can't obviously do in production. That would be an unacceptable thing to do. And just to show you guys, in case you've forgotten, if we go to our Postgres database and we can see that we've got our 3 tables. Now, if I add a phone number column to our user class, and I'll set this column to be just a string, and this is really just for demonstration purposes. You guys don't have to do this. If I save this and reload this, SQL Alchemy will not go into Postgres and actually create that column. If I refresh this and then go into users properties, you can see that it is not here. And so that's the limitation of SQL Alchemy. And so in this section, what we're going to do is we're going to take a look at another tool that'll allow us to do a couple things. First of all, it's going to allow us to automatically update the columns based off of the models that we define here. So moving forward, when we add this phone number column, it's going to automatically update our Postgres database. And this tool is called Alembic. It is what we refer to as a database migration tool. However, it's much more powerful than that. Right? It's able to allow us to create incremental changes to our database and actually track it, kind of like we do with code. So in this lesson and in the next coming lessons, we're going to take a look at Alembic. We're going to see everything it has to offer. And I'm going to hopefully get you guys at least a solid understanding of how to work with Alembic so that when you guys work on your projects, you can immediately get Alembic installed, running, and then manage your databases using Alembic instead of having to either do it manually or use any other kind of unusual workaround. Now, one of the motivations for a database migration tool came from the fact that developers can track changes to their code and roll back their code easily with Git. And they wanted to be able to do the same thing for our database models and our database schema. And so they went about implementing what is referred to as database migration tools. And so a database migration tool just allows us to incrementally track changes to our schema and roll back those changes to any point in time. And so as we go through our project, we kept adding new tables and new features. What a database migration tool is, it's going to allow us to track those changes. And so if we ever want to go back to a specific point in time so that we can kind of troubleshoot code at that point in time, it's so easy. It's just one simple command and it's going to automatically update our database so that the schema matches what it was at that specific point in time. And so that tool that we're going to use, like I mentioned, is going to be Alembic. And what's great about Alembic is that it can also automatically pull all of our SQL Alchemy models and generate the proper tables based off of them. All right, so this is the documentation for Alembic. So it's just alembic.sql.com.org. And if you want to kind of follow along, just select the tutorial right here. And this is just going to give you kind of a quick walkthrough of how to get Alembic set up. But I'm going to show you guys this so you don't actually have to follow the tutorial. So we're going to do first of all, we have to install the library. So we'll do pip install Alembic. And so that'll get Alembic installed. And what it does is it actually gives us access to the Alembic command. So if I do alembic --help, and actually before we proceed any further, I want you to go ahead and delete phone number. We don't actually need that anymore. And then go to your application and actually close that out. Stop it so that it doesn't automatically restart for any other reason. And then also what we're going to do is I'm actually going to delete all of our tables so that we can actually take a look at how this works. So do delete drop. And if you try to drop this table, it's going to say we can't drop it due to the foreign key constraint. That's okay. We could just do drop cascade and that's going to delete it. And we're just going to do that for all of them. All right, so now let's get back to Alembic. I'm going to make this bigger for you guys. All right. And so we'll do alembic --help to see what commands we have. And the first thing that we have to do is we have to initialize Alembic. And what that's going to do is it's going to actually create an Alembic directory for us. So we'll do Alembic init. And then I'm just going to do a dash dash help to see if we need to pass in any extra flags. And then we have to give it a directory name. So when we run this command, it's going to create a directory. I'm going to name the directory Alembic. You could call it DB, database, whatever you want to call it, but I'm just going to call it Alembic. So it's going to create a folder called Alembic. And so you can see that we've got this folder called Alembic, and notice how it gets installed outside of the app folder, which is what we want. And it also created this alembic.ini file. So we'll take a look at both of those. And the first thing that we want to do is go up into Alembic, and there's really one main file. It's the env.py. So this is kind of like the King Kong configuration file. And there's going to be a couple of things that we have to add to this file to make sure that things work. Because Alembic works with SQL Alchemy and the models that you build with SQL Alchemy, we need to make sure that it has access to our base object right here. So we have to import this base object into the env.py file. So I'm going to just go right here, and we're going to say from, and what we're going to do is, how do we actually get to that database file, that base object? We have to go into app, and then we go into database, and then we'll import base. All right, and so this is kind of give us access to all of those SQL Alchemy models. And then for target underscore metadata, instead of saying none, what we want to do is we want to get base. So we're accessing, this should be a capital B. Actually, let's just double check that it's capitalized. Yep, it's capitalized here. So we'll go to base, and then we want to make sure we grab metadata. So that's all we have to do to rig this up to SQL Alchemy. The next thing that we have to do is if we go to alembic.ini, we have to pass in one value here, which is the SQL Alchemy URL, which is basically what's the URL to access our Postgres database. And so just to show you what this is going to look like, this is going to be fundamentally no different than the URL that we used within database.py, which is this one right here. And so I'm just going to write this out. Just going to copy this first part right here because I can never remember that. And so here, just going to copy that. So we say PostgreSQL. And optionally, with the URL, you can do a plus and then whatever driver you're using. So if you don't provide the driver, it's going to use whatever the default driver is. But we're using, let's see, which driver, what is our driver? If I do pip freeze, it's going to be this one right here. So this is the default driver for Postgres. So you don't actually need to provide it. But if you did, you could just say plus PSY COPG2. But like I said, it's the default one, so it's optional. Right, then we have to give it the username. So what's the username that's going to be using to log into your Postgres database? For me, it's just Postgres. The password is going to be password123. It's going to be running on localhost. And then if you want to, you can provide the port, which is 5432, and then your database name, which is Fast API for me. So this is ultimately what the URL is going to look like. And at this point, Alembic is set up and ready to run. However, just like we did before, I don't like the fact that we're hard coding this data in here. It's gross. We're saving our password. And if we move into our production server, it's not going to work properly because they're not going to use these credentials or this IP. So instead of doing this, what we're actually going to do is we're going to override this value that's stored in this file within the env.py file. And so under this config right here, I'm going to set a new option under the config object. I'm going to say config.set underscore main underscore option. And then here we can override any options that we have in here. So I'm going to override this SQL Alchemy URL. So no matter what I put in here, we're actually going to override it. And here you just pass in a string. So SQL Alchemy.url. So that's the value we're going to override. And then we're going to pass in our string. So I can just cut this out, and it's okay to just leave this blank here. All right. And so we've hard-coded this string here, so we haven't technically fixed anything, but what we're going to do is, just like we have in our database.py file, you can see that we're using the settings object, right? That comes from our config file, which is making use of this Pydantic class, where we can grab it from our environment variable. And so what we're going to do is we're going to do the same exact thing we did with main, right? We imported settings, and we're just going to do that in our env.py file so we can access all of our environment variables. So I'm going to say from app.config import settings. And so now I have access to the settings object. I can override all of these. So this is going to be the username. So I can say settings.username. And actually, I don't think that's what it is. It's database_username. And then we'll override the password, which is settings.database_password. And in reality, instead of just typing this all out myself, we actually have this written out in our database.py file. So I can just copy this here. And that way we don't waste too much time. Okay, so we've got our URL set and we're not hard coding any values. And at this point, Alembic should be set to actually connect to our database and modify any of the tables, generate tables, and be able to really perform any actions that we wanted to moving forward. Hey guys, I made one tiny little mistake. If you take a look at where we're importing base, I wrote app.database. And if we take a look at that, it looks like we are grabbing our base right here, but this is not the one we want. Instead, what we want to do is we want to import it from models. So we want to import base, which is technically getting imported from that same file. But by doing it from here, it'll allow Alembic to read all of these models. And if we do it directly from database, it's not going to work. So what I want you guys to do is go to your env.py file and just change this from app.database to app.models. And that should fix any potential issues that you could have. Okay, so just to quickly recap, we have cleared out all of our tables, so there's nothing in our Postgres database. We don't have any tables defined, and we're going to do this all through Alembic. But what I want to do is I want to kind of go through this like we would have if we had already known about Alembic from the start of our project. And so we're going to take this step by step, right? Because when we first started creating tables in our Postgres database, we kind of went along with what we were working on in our app. So the first thing we did was we created a post table. And that's because we didn't learn about how to actually create users. We didn't learn about hashing passwords. We haven't gotten to the user section. So we originally just had a post table with a couple of fields. And then after working through our code, once we finished all the CRUD operations for posts, we then learned how to register users. And at that point, we had to create a table for users. And then after that, the next logical step was, hey, how do we set up the relationship between posts and users? Then we had to modify that and set up a foreign key. And then finally, after that, the last thing that we had to do was we created a voting table or a votes table, and then we set up all of the necessary foreign keys for that. So we're gonna do this step by step, just kind of like how we did it with our project, but we're gonna do this with the database so that you can see how we would have done it if we had already known how to work with Alembic. All right, so first things first, do Alembic --help, just to see what commands we have. And so there's a few different commands, but the first one that I want to focus on is revision. So when we want to make a change to our database, we create a revision. So the revision is what really tracks all of the changes that we make on a step-by-step basis. So we're going to do Alembic revision --help, and we'll see the different options that we have in our disposal. The first one is that really the only one that I care about is the -m flag. So it's kind of like when you do a git commit, you can add a -m, a message, so that you can kind of have a human readable name associated with each revision. So I'm going to say Alembic revision -m, and I'm going to say this is going to be create post table. So this revision is going to be responsible for creating a post table. We'll run that. And I want you to notice something, right? You can see that it created this file under the versions. So the versions folder under the Alembic folder is going to contain all of our changes. And if we take a look at the revision, there's a couple of things to note. So you'll see that we import OP from the Alembic library, and then we import SA from the SQL Alchemy library. And then you can see the revision ID that it gives it. And then there's going to be two different functions that are empty at the moment. So these functions are pretty important. What they are is the upgrade function. When we run the upgrade, what it does is it runs the commands for making the changes that you want to do. So in this case, we want to create a post table. So what we're going to do is we're going to put all of the logic for creating a post table within this function. And then if we ever want to roll back, right? If maybe I create the table and I realize I messed it up and I don't want it anymore, then we have to put in all of the logic in the downgrade function to handle removing the table. So the upgrade just handles the changes and the downgrade handles rolling it back, but it's all manual. You have to define how to do all of that. So let's go ahead and set up the upgrade function and let's configure all of the necessary columns for our post table. All right. And if you ever want to take a look at the documentation for this, what you want to do is select documentation here, and then you want to go down, 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 all the way down to API details, and then you want to go to DDL internals. So this is going to show you how to actually perform the various operations. So if you want to create a column, if you want to add a column, this is the command that you're going to run. If you want to alter a column, if you want to modify a table, drop a column, create a table, all of these are all listed here. So this is the sheet that you're going to reference on a fairly frequent basis when you're working with Alembic, because I can never remember each of the things. But we're going to go ahead and create our post table. And so we access the OP object from Alembic. I'm going to say OP. And then if you look at the documentation, the way to create a table is you do create underscore table. And there's going to be a couple of properties we have to pass in. So what's the name of the table in Postgres? Well, we're going to call it posts. And then we have to define our columns. And I'm not going to do all of our post column because it's going to take a little bit of a while, and we might do it later on, but we're just going to define two columns. So the first one is going to be, well, first of all, we do SA column. So we're grabbing the SQL Alchemy object. And so this column is going to represent the ID. So the name of it's going to be ID. It's going to be type of integer. And I may have accidentally imported, nope, we're good. So integer. And then we can set nullable equals false, which means it's required. And then we also want this to be the primary key, so you just do primary key equals true. All right, fairly straightforward, right, guys? So we can then go in and create a second column. And so this is just going to follow the same exact pattern, sa.column. And then this one will be the title. It's going to be a type of sa.string. And this is going to be nullable equals false. And I'm just going to stop it right here. So we're going to just create two columns. I don't feel like creating all of the columns that we had for post. And so the upgrade function is done. However, we also have to provide the logic for undoing these changes. So if we create a table, how do we undo that? Well, we delete the table. So we do op.drop underscore table, and we just give it the name of the table. So it's going to be posts. All right. And so now we should be able to make these changes, and then we can roll back because we put the logic in for downgrading. So how exactly do we make these changes? Well, let's go to Alembic --help. And let's see what commands we have. So we've got a couple branches. That's probably not it. Current, that's going to show us what's the current revision, like what version are we on. And if you actually want to see that, we'll see Alembic current. And it looks like it's giving me an error. Hold on. Let's go back to my env.py file. And I made a very silly mistake. This should be an F string, so it wasn't actually doing anything. That's why it was kind of highlighted weird. So let's try this now again. We're going to do Alembic current. And it's not going to actually really give us any useful information at the moment because we haven't run any migrations, right? We're kind of starting from a clean slate. So let's go back and let's just do a --help and see what else we've got. So we've got a downgrade. Well, we don't want to downgrade. Edit, not really. Heads, we'll come back to that. History, that's not going to be useful because we haven't done anything. But if we go down, we want to get to upgrade. So this is what's important. So if we do Alembic upgrade, we could just do --help and we'll see what options we have. And so we have to provide a revision number to tell Alembic like, hey, what version of our database do we want to go to? And so if you actually take a look at this specific revision, it provides a revision number. So if we actually want to get up to this point where it runs this upgrade, we provide this revision number. So I can say Alembic revision and then paste that. So let's run this and see what happens. Sorry, I didn't mean to type revision. I meant Alembic upgrade and then not Alembic revision. So that's going to upgrade it. And so you can see it did a couple things. It said running upgrade and it said it created post table. So let's go to Postgres and let's just refresh this and let's see if it actually did something. Right? And it looks like it created 2 tables. So that's interesting. So we see our post table and let's just quickly inspect this. We'll go to columns. You can see that it created these columns and this one got set to the primary key and both are not null. So it looks like it did everything it was supposed to do. But what is this Alembic versions table? Well, this is what Alembic uses to kind of keep track of all of the revisions. And so if we just go to view, edit, data, all rows, you can see that it just has one column at the moment, which has the revision number. You can see it's D18 and that's going to match up with this file D18. So that's all that's doing. So it will create a table for you automatically so it can keep track of all of the revisions, but make sure you don't delete that. Okay, so that's cool. We just got our first table created through Alembic. And I think at this point, you probably still don't understand the brilliance of a database migration tool. And that's okay because we haven't really done much with it yet. So let's say that, as we're coding out our application, we realize we want to add a new column to our database. Specifically to our post table. Well, we can create a brand new revision to add a new column. So let's say, if you take a look at our models, we have a couple other fields that are missing. So let's say we want to add the content column now. I can type in Alembic revision. So this is going to create a brand new revision. We'll give it a name and I'll say add content column to post table. All right, and it's going to create a brand new revision for us. And once again, we have to put in the logic for upgrade and downgrading. And you can see that now that we have more than one revision, we can see that there's also a down revision. So if you want to go down a step, it's going to go to the revision of the previous one. So let's put it in the logic for creating or adding in a brand new column for content. And the way we add a new column is we do op.add_column. And then we specify the table we want to modify. So it's going to be the post table. And then we do sa.column to define this column. So what's the column name? It's going to be content. And it's going to be a type of string. And we're going to make sure that its nullable is set to false. All right. And remember, every time you set up the upgrade function, you have to set up the downgrade function. So if we add a column, how do we undo that? Well, we drop the column. So it's just op.drop_column. And then from the post, we have to provide the table that we want to drop the column from, which is the post table. And then we need to provide the actual column we want to drop, which is going to be content. So we'll do content. Okay, and so let's test this out. First of all, we'll run a few new commands. So Alembic. All right, and let's see what the current revision is. So if I do Alembic current, right, we could see that we are currently on 2D18. That's the revision. So this is the revision where we created the post table. And if I type in the Alembic heads, we can see that the latest revision is actually 298A5, which is that new one we just created. So if we ever want to get to the latest revision, that's what's referred to as the head. So I can say, if we want to, upgrade to that revision, I can say Alembic upgrade like we did before. And I can grab the revision number like this. Or because it also happens to be the head, I can just say Alembic upgrade head. And it's going to do the same thing. So let's try this. All right, it said it added a content column. We'll go and check this in Postgres. And I'm just going to refresh this table. And we'll go into properties. And we can see that we added the content. Now, let's say that after working on this for a bit, we realize we want to undo these changes for whatever reason. Maybe we no longer want the content column. So how do we actually roll back? Well, since upgrading makes the changes, downgrading is going to do the opposite. So we can do alembic, downgrade. And then if you want to just roll back this revision, we can see what the down revision is. So we can just say this and just paste that in there. But we can also do a few other things. We can also say -1. So when I say -1, that means I'm going to go back to one revision earlier. And we can even go as far back as we want. So if I say I want to go back to -2, it's going to go back to 2 revisions earlier. But we just have 1, so I'm just going to say -1, or I can just paste in the revision number. And so if I run the downgrade, you can see that it ran this downgrade. And if I go and refresh this, and then go to properties, columns, we can see that we no longer have a content column. And that's how easy it is to downgrade or roll back your database using a database migration tool like Alembic. Okay, so we got our post table. We're not going to worry too much about that. The next part of our application was, hey, let's implement user functionality. Let's make it so that users can sign up and log in. So now we need to create a users table. How do we do that? Well, let's set up a new revision. We'll do Alembic revision-m, and I'll say add user table. All right, so we've got our brand new revision, and we have to set up the upgrade and the downgrade. Now for this, I don't want to just type this out, one by one. It would be kind of slow and boring for you guys. So I'm just going to copy and paste this from my notes. And if you want to follow along, just, pause the video and just write this out. But we'll just quickly, walk through exactly what's happening. So once again, we're using the create table method. We're going to create a table called users, and then we're going to set up all of our columns. So we've got a column called ID, which is an integer set to nullable equals false. You notice how I haven't set this to be the primary key here? That's because there's 2 different ways to set the primary key. If we go back to the previous one, we set this to be primary key equals true. But on this one, if you actually go all the way down to the bottom, you can see that we can add in a constraint, SA primary key constraint, and then we pass the name of the column. That's going to be the primary key. So they both do the same thing. It's just whatever method you prefer. We've got the email column, which is going to be set to nullable equals false. Same thing with password. Then we've got the created at. And so here it's going to be of type timestamp. And you'll see that this is all coming from SQL Alchemy, essentially. Because if we go to our models and we go to our user table, it's the same thing. Type timestamp, time zone equals true, nullable equals false, server default equals text. Well, that's created at, but yeah. And we're just doing the same thing. So server default, and then we grab sa.text, now nullable equals false. And then you can see that we added a unique constraint under the email field to ensure that we can't have duplicate emails. And then to downgrade, we just do op.drop_table users. All right. And so once again, if you want to see where we currently are, because remember, we had originally upgraded, added the content column, but then we downgraded. So where exactly are we from a revision perspective? Well, let's do Alembic current. You can see that we're on 2D18. So we're back on that first revision. And we can also do an Alembic, I believe it's history. And you can see the history of our revision. So we created post, add content column to posts, and then add user table. And this is the head. So if you want to go all the way to the front to the latest, you would just do Alembic upgrade head. And I think there was one more I want to show you. Yeah, that's okay. So we're going to do an Alembic. And let's say that we just want to go and go up one revision. So adding one revision is going to add that column back. We can do Alembic upgrade. And we can either put in the name of this revision, or we can upgrade one level. If we want to go all the way to the latest, which is going to be adding the user table, we can say head. We can also go up 2 revisions. So if I do +2, that's going to go up to add content column 1. That's the first revision. And then one more, which is going to go up to the latest in this case. So there's a lot of different ways to get there. I'm just going to go to the latest. So this is going to add the column back in the post table and then add the users table. And you can see that it went ahead and added the users table. So if I refresh this, we can now see that we have a users table, and hopefully all of the properties are there. You can see all of these have been set. Constraints, primary key is set, and everything else looks good. I guess one thing just to check is the created at. So if we check the constraints here, you can see that we're going to grab the current time. Perfect. All right, so after we had added the user functionality, the next thing we had to do was we had to implement the relationships between users and posts. So we had to set up that foreign key that linked the user table to the post table, or the post table to the user table. So once again, we're going to do an Alembic revision -m. And I'm just going to say add foreign key to post table. All right, we got our new revision. And what we're going to do is first of all, we have to add a column to our post table called owner ID. And that's going to be the one that has the foreign key constraint. So we have to do op.add column. And we have to specify the table we want to add the column to, which is going to be the post table. And this is going to be sa.column. We're going to call this owner_ID. And it's going to be a type of SA integer. And nullable is going to be set to false. All right, so we've created the column. Now we have to set the link between the two tables, which is going to be the foreign key constraint. And so to do that, this is a little bit confusing at first for me, because the documentation is a little bit hard to read sometimes. So you do create foreign key. Then you have to give it, some arbitrary foreign key name. I'm going to call this posts_users_fk. So this is the foreign key between the posts and the users table. And then we have to specify what is the source table of the foreign key. So this is going to be the foreign key for the post table. So we're going to say source_table equals posts. Then we have to reference the remote table, which they call a referent_table. And so this is going to be the users table. And then we have to specify what is the local column that we're going to be using. So the column in the post table. And that's going to be owner_ID, which is the table, the column that we just created. And then finally, we have to specify the remote column in the users table. And this is going to be set, and we're also going to set the onDelete to be cascade. And yeah, by the way, the remote column is going to be the ID field of the user table. And we want to make sure we have the onDelete as well. And that pretty much, what happened there? It's a weird way to format things. All right, well, it wants to format it that way, so I'm just going to leave it like that. Let's set up the downgrade now, so we have to undo those changes. We'll do op.drop_constraint. And then we just mentioned the name of the constraint, which is post_users_fk. We have to specify the table that we're removing it from, so it's on the post table. So we do table name equals posts. And then we have to drop the column, so we do op.drop_column. And where does this column sit? It's in the post table, and it's called owner_ID. All right, and so if I do an Alembic current, we're on F52 and Alembic heads. Let's see what the latest one is. It should be 296, which is this one. So let's do an Alembic upgrade head. Go to the latest. And I have a typo, so this should be integer. All right, looks like it ran with no issues. Let's double check that the foreign key is there now. If we go to posts, properties, constraints, foreign key, you can see that we have our post user FK And we can see that it points from owner ID in the post table to ID in the users table. And if you want to, you can go under actions and see that cascade has been set to on delete. Now in our post table at the moment, we didn't implement all of the columns that we actually have in our application. So I figured, why not just go in and add it? Might as well. So I'm going to create a new revision. All right, and then when we go to that revision, there's really only 2 more columns that we have to add. And this is, I'm once again going to just copy and paste from my notes just because I don't want to waste your guys' time too much. But you can see here, we're going to do an add column and we're going to add it from our, add it to our post table. And then here we're going to specify the parameters of the column. So this is going to be called publish. It's going to be of type Boolean, and nullable equals false. And that's not correct. It should actually be nullable equals true, right? It should be, actually, no, it was false. And then server default is set to be true. So if we don't provide it, it's going to assume it's true. And then the next one is the column for created at. So once again, at the post table, we're going to create a column called created at. It's going to be of type timestamp, nullable false, and then the default means we're going to grab the current time. And to downgrade, we're going to delete those columns. All right, and let's do a Alembic upgrade. And we'll just go, instead of doing head, we can just do +1 just to show you guys how it's going to do the same thing in this case. And so it looks like it ran that. And if we go back to Postgres, refresh this, and then go to properties, we should see we've now got our published and our created at columns. All right, and once again, let's say that maybe we want to roll back, right? Maybe we want to roll back all the way to back when we just created the post table. We can once again do Alembic downgrade and just provide the revision number of the specific revision you want to go to. So we can go down to add user table. We can go down to create post table. We can go down to any section we want. And it's really up to you. And so let's say this time, let's just go all the way down to, let's go down to add user table. So whatever revision this is, we can do that. All right, and so it deleted a whole bunch of stuff. Looks like it deleted the last few columns that we just added, as well as the foreign key constraint. And so now, if we refresh these tables, you can see that posts, it doesn't have the extra columns we added, and the constraints, foreign key, no longer exist. But fortunately, we can upgrade to a newer version, to one of the more recent versions. So I can do Alembic upgrade +1. So if I do this, it's going to go up 1 newer revision. So right now we're at the add user table. And if you forget wherever you are, you could just do Alembic current. All right, so we're on 32F52. And so if I do an upgrade, right, we're going to go up to, I think it's this one. Because you can see that in this one, this revision is 296, but the previous revision is 252, which is the one we're currently on. So I can do Alembic upgrade +1. All right, and so now we've added the foreign key. If I do Alembic current, we can see that we're on 296. And then if I just do Alembic upgrade, well, Alembic heads, it's going to show us whichever one's the latest one, which is 5B7. So we can just go upgrade directly to that by doing head. The last thing that we have to do now is generate the votes table. But I'm not going to manually create it myself this time. Instead, I'm going to make use of the auto-generate feature. So this is what I was talking about earlier, how we can use Alembic to be intelligent enough to figure out what exactly is missing from our Postgres database and figure out what needs to be created. And the way it actually does that is it takes a look at all of our models. So it's going to import all of our SQL Alchemy models, and based off of the columns that we have set here, it's going to figure out what our Postgres database is supposed to look like. And regardless of what our database is in its current state, we don't need to actually delete everything and build it from scratch. Instead, Alembic is going to be intelligent enough to figure out what columns are missing, what tables are missing, what extra columns do we currently have that we may need to remove, and it's going to figure out what's different between SQL Alchemy's models and our Postgres database, and it's going to make the necessary changes for us. And so the way to do that, and first of all, I guess just to kind of reiterate, the reason we can do that is because we imported the models and then we passed it into this target metadata. So let's run Alembic and we'll do revision. But if we do -- help, you'll see that we're going to use one of the flags that we have never used before, which is the -- auto generate. So we'll do -- auto generate. And then we will send a message once again. We'll say add votes. How about auto vote? Maybe. Because it's auto-generated and I know it's going to add the votes table because that should be the only difference that we have. So we'll run that. And so if I go to auto vote, let's take a look at the changes it's going to make. And so you can see here, the changes where it looks like it's going to create the votes table like I had predicted. It's creating the 2 columns, and then it's going to add the primary key constraint as well as the 2 foreign keys as well. And it's going to even add in all of the on-delete properties and things like that. All right, and so all we got to do now is do an Alembic upgrade head. And now if I refresh this and go to votes and properties, right, we should have the 2 columns, and then our constraints and foreign keys look pretty good. Everything looks set. And so that's how easy it was. So no matter what state your database is at any point in time, you can always do the auto generate functionality to get it back to a state that your code expects it to be. And the best part about this is moving forward, let's say I want to go back to my models and I want to change something. So I've got my user model. This time I'm going to add that phone number column. And this is going to be string. All right, so any changes we make, even on a table that already exists, what we can do now is I can do a revision auto generate. Here I can just call it add phone number. All right, and then if we go take a look at that, we can see that, hey, look, we added our phone number column. And so the only thing else we have to do is do an Alembic upgrade head, and it's going to push out those changes. So let's refresh this and let's just double check. We go to users now, properties, we can see phone number column is now set. And I think that's pretty much going to wrap up everything I wanted to cover from Alembic. So moving forward, now that we have Alembic, we no longer actually need this command in our main.py file. This is the command that told SQL Alchemy to run the create statement so that it generated all of the tables when it first started up. But since we have Alembic now, you no longer need this command. However, if you want to keep it in, it's not really going to break anything. It just depends on how you want things to work, because if it does create the tables for you, then your first Alembic migration isn't going to have to do anything because everything is already there. But I'm going to leave this commented out moving forward because I don't really need it. And it's really up to you guys for what you guys want to do. For the most part, throughout this course, we've been testing our API by sending a request from Postman. And Postman's a great tool, but there's one thing to note, and that is that when you send a request from Postman, you're actually sending a request from your own computer. And it's important to understand this because your API can get requests from different types of devices. You can get a request from a computer or a server, whether that's through Postman or even through curl. If you've ever used curl, it's essentially doing the same thing that Postman's doing. It just doesn't have a nice little GUI. You can also get requests from mobile devices, but more importantly, you can get requests from a web browser. So when a web browser sends a request, using JavaScript's fetch API, there's going to be a slightly different behavior that we have to account for which we can't take into consideration when sending requests with Postman because Postman isn't a web browser. So what I'm going to do is I'm going to show you exactly what happens when we send a request from a web browser instead of our own computer using Postman. So what I want you guys to do is open up your web browser and specifically go to google.com. It's important that you go to google.com, or technically this is going to work on any website, but I need you to actually go to a specific website like google.com. And then I want you to right click on the web browser and just hit inspect. So this is going to open up the Chrome developer tools. And if you aren't too familiar with it, don't worry. It's just it's a built-in tool that we have in Chrome or any web browser that allows you to makes it easier as a web developer to kind of troubleshoot things. But what we can do is if you go to console, we can actually send an API request to our API from google.com or from our web browser, which is on the google.com domain at the moment. And so I want you to just type this in. We're going to say fetch. So this is how you perform an API request from the web browser level. And we're going to send a request to our fast API. So that's going to be hosted on http://localhost:8000. And then just type in then. So don't worry too much about this, but it technically returns a promise. So we have to resolve the promise. We just say res.json. And then do another then and just say console.log. And I forgot one bracket right here. And so all this is doing is it's sending a request to the root URL of our API, and then it's going to print out the contents of whatever we get back from the server. So when I run this, I want you to notice something. We get an error. It says access to fetch localhost:8000 from origin, and then it has google.com here, has been blocked by CORS policy. So what is happening here? Why is it that I can't send a request from the web browser, but if I go to Postman and I just create a quick new request, and we can just go straight to URL, it resolves just fine. Well, it has to do with this CORS policy. So in this lesson, we're going to take a look at what exactly this CORS policy is and what we can do to ultimately resolve this issue. So what exactly is CORS? CORS is short for cross-origin resource sharing. And so CORS allows you to make requests from a web browser on one domain to a server on a different domain. And by default, when you configure an API, whether it's in Fast API or any other framework or language, you will only be allowed to send requests from a web browser running on the same exact domain as your server. And so what exactly do I mean by that? Well, if our API is hosted on google.com and our website is hosted on ebay.com, ebay.com by default cannot send a request to an API running on a different domain like google.com. It's going to get blocked by CORS. However, if our website was also running on google.com and our API was also running on google.com, then they'd be able to talk just fine by default. And just to prove that to you guys, if we go to our web browser and go to localhost:8000, which is the URL that our application is currently running on, you can see that I get a response back. So our web browser was able to make, and by the way, when I did this, right, it did the same thing as going into Chrome Developer Tools and actually sending a request. And just in case you don't believe me, I'm just going to actually just show you guys even on here. So if I paste it, you can see that it was able to resolve, and we can see the hello world. So the reason why it works on this website is because this is the same exact URL or domain name that our API is running on, right? Our API is running on localhost:8000. So by default, they're able to talk to one another only when the web browser domain is on the same exact domain as the API's domain. So to fix this, if you did want to allow people from other domains to talk to your API, what you can do is take a look at the Fast API documentation and just search for CORS, cross-origin resource sharing. And you'll see that setting this up is really simple. So the first thing that we have to do is from Fast API, middleware CORS, we're going to import CORS middleware. All right, and then just copy this section right here. And I'll explain line by line exactly what each one's doing. And so under the app right here, we'll just paste this in. And it's going to throw a little error here, but we'll come back. You can actually delete that and change that to an array for now. But what we want to do is, first of all, we have to pass in the middleware. And middleware is a term that's used in most web frameworks because it's basically a function that runs before every request. So if someone sends a request to our app, and before it actually goes through all of these routers, it'll actually go through the middleware, and then our middleware can perform some sort of operation. But what we want to do is, first of all, we have to specify the origins that we want to allow. So what domains should be able to talk to our API? Because right now it's no domains. Only if it's running on the same exact domain are you able to talk to our API. So the way we can do it is we can put in, we'll create a list called our origins. And I'll say origins equals, and it's just going to be a list. And here we're going to provide a list of all of the domains that can talk to our API. And before we fill that in, I just want to quickly talk about the other three as well. So our CORS policy can be pretty granular. So not only can we allow specific domains, we can also allow only specific HTTP methods. So if we were building like a public API where people can just retrieve data, we may not want to allow them to send post requests and put requests and delete requests. So we could potentially just allow GET requests. And then we can even allow specific headers as well. But for now, we're just going to allow all headers and all methods. And we're going to just kind of drill down based off of what origins can talk to us. And so, if we want Google to be able to talk to us, I can just say https://www.google.com. And so now this CORS policy is set to allow people from google.com to talk to us. And so if I go back to google.com, I just hit the up arrow so I can run this command again. You'll see that I do successfully get a response back and there's no CORS error. However, if I go to a different website, so some website on a different domain like youtube.com, and then we go and then we send the same exact request from the console, right? We once again get the CORS error. And that's because in our list of origins, we're not providing www.youtube.com. So if you wanted to also allow youtube.com, then we'd have to do https://www.youtube.com. So now if I hit the up arrow, we can see that it properly resolves. So you just have to provide the list of URLs that can talk to your API. And if you want to set up a public API so that everyone can access it, then your origins would just be a wildcard. So this means every single domain or every single origin. But if your API is being configured for a specific web app, then you definitely want to make sure that you provide a strict list of origins. So just whatever domain your web app is running on, so that no one else can, accidentally reach our application for some reason or another. It's just security best practices to really narrow down the scope of the origins that can actually access your API. For now, I'm just going to leave this as set to everyone so that when we actually go to deploy this, it'll be a little bit easier from a testing purpose. But feel free to update this accordingly. In this lesson, we're going to focus on setting up Git for our project so that we can start tracking our changes, as well as set up a remote repository to store all of our code. This is going to make the whole deployment process a whole lot easier. But before we set up Git, there's a couple of things that we need to do. Because when you check your files into Git, by default, it's going to check in all of your files. And there's going to be some files that you don't want to be uploaded to a remote repository or even into your Git in general. And so we have to create a file called a git ignore file. And so if you go to the main root folder of your project, I want you to create a file called .gitignore. And it's important that you put the dot in front of it. So it's .gitignore. And so this file is going to tell Git what are all of the files and folders we don't want uploaded to Git. And so some of the common things that you would not want to be tracked within Git is going to be your .env file. So this is going to be all of your environment variables. Obviously, you don't want to check those in, or then if this is part of a public repository, then anyone can see those. But also on top of that, you'll see all of these random PyCache, these __ PyCache folders. So go ahead and add that in there as well, because we don't actually need to check that into Git. And then finally, we have our folder which contains our virtual environment. We don't want to check that in as well, just because we have no idea if someone else who wants to clone our repository is going to be using a virtual environment. And if they are, then they can create one on their own. There's no need for us to actually upload our virtual environment. It just wouldn't make sense. And on top of that, our virtual environment contains all of the third-party libraries that we've installed. So all of the different packages we installed through pip, including Fast API itself. So all of the code of Fast API is within that virtual environment folder. And so there's no need to actually upload all of that because that's a lot of files that actually take up a decent amount of space, and it just wouldn't be efficient to actually upload those to Git. However, this does create one bit of an issue because if we clone the repository at this point, right, we have no idea what packages we need to install because our virtual environment didn't get uploaded with it. So we need a way for other users, other people on our team to know what packages and dependencies we need our application so that our application actually works. And so the way that we actually do this is, well, first of all, before we even proceed, go ahead and copy this into your git ignore file and make sure you have this before you do anything else, because once certain files get checked in, it's very hard to get them removed. But after this, what we want to do is we want to create one more file and open up your terminal. And what we're going to do is type in pip freeze. So pip freeze is going to dump out all of the different packages and libraries that we have installed, as well as the specific versions. And so this is the information that we want to upload to Git so that if anyone else clones our repository, they'll know the exact versions of every package they need to install. So what we're going to do is we're just going to take this output and we're going to pipe it to a file. And the file name is going to be called requirements.txt. So this is standard convention with any Python application. You want to create a requirements.txt file that's going to contain the version of all of the different packages that you have installed. And so if we check this into Git now, then anyone else can just take a look at our requirements.txt file and then actually install dependencies based off of what's in this file. And so for anyone else that clones our repository, all they have to do, instead of going one by one and installing these, they can just type in pip install -r requirements.txt, and that's going to install everything that's in this file. So this does simplify the process, and it prevents us from having to upload all of those third-party packages into Git. But we've got everything set up at this point. We've got the git ignore file, and we've got the requirements.txt. So what we need to do now is actually set up and install Git on our local machine. If you don't already have Git installed, then in this lesson, we're going to focus on getting installed on your local machine. So just search for Git, and then you can either go to the main page or you can go straight to the downloads page. So I'm just going to select the downloads page. And then here you're going to see the different operating systems we can install Git on. And so just go ahead and select your respective operating system. I'm on a Windows machine, but regardless of your operating system, it's going to be a fairly similar procedure. So I'm going to select this. It's going to download that. All right. And then when the wizard opens, go ahead and select next, next here. And you can leave everything default here as well. And here, and here. Now, this is the one thing that we do have to change. So this is kind of a little bit of a nuisance at this point, but they used to call like the main branch the master branch, but I guess people are offended by that. So now the new term for the main branch is main. So go ahead and override the default branch and just change that to main. Because when you work on GitHub, they've already changed the default branch to be main. So we're going to want to do the same thing. So hit next. And then you can leave everything as default moving forward. There's a lot of windows to go through. And then it's going to proceed to install Git. All right, close that out. And then what you want to do is open up a new terminal. And just type in git -- version. And if it spits that out, that means you've got Git successfully installed. In this video, we're going to set up a remote repository so we can store all of our code on GitHub. And so if you don't already have an account on GitHub, go to the main GitHub page, just go to github.com and just click sign up and then follow those instructions. And then once that's done, just log in and you should see something similar to this, although you may not see an activity window if you just